Hello everyone, welcome back to our Unity FPS controller series. In today's episode, we're going to create a realistic bullet tracing system, just like you see in modern FPS games. We'll create a reusable bullet tracer that works with our shooting system and makes every shot feel much more satisfying. So, without wasting any more time, let's get started. The first thing we need is the bullet tracer itself. Instead of creating an entire bullet model, we're going to use Unity's trail renderer. The reason is very simple. Most FPS games don't actually render every bullet flying through the air. Instead, they create a very fast trail that gives the illusion of a bullet traveling at high speed. This approach looks great and is much more performance friendly. Inside the hierarchy, right-click, go to Effects and create a trail renderer and name this as Bullet Tracing. This trail will act as bullet tracer. Now let's configure our trail renderer. The very first setting is width. I'm setting the width to 0.04. After that, change the time value to 0.2. Next, we have min vertex distance. I'll set this to 0.02. After that, we have end cap vertices. I'll set end cap vertices to 2. After that, disable the receive shadows, and then turn cast shadows to off, and keep the remaining settings as it is. Now, let's set the color for our bullet tracer. Let's add a new color node at almost 25%, and set its color to light yellow. Add a new node at 70% location, and set the color to orange. And at 100% set the color to orange, and at 100% set alpha to 0, add new alpha node at 70%, and set alpha to 180. That's it for color setting. Now close the color window, and let's test the trail in scene view by dragging trail forward and backward. And you can see the trail effect. Now our bullet tracer prefab is ready. Next, we need to create a couple of scripts. One script will be responsible for spawning and managing the bullet tracers. And another script will be responsible for moving the tracer from the weapon muzzle to the hit point. Let's create the first script and name this as Bullet Tracer. Double-click to open the script in Visual Studio. First of all, let's remove mono behavior because we don't need this script as a normal component. And now let's add serializable attributes. This allows Unity to show this class in the inspector when we add it inside our weapon controller, and remove start and update methods. First of all, let's add the bullet tracer prefab. This is the tracer prefab that we created a few minutes ago. Let's add serialize field, private, game object, bullet tracer prefab. Every pool tracer will be created from this prefab. Now above this line, let's create a private list. This list will store all bullet tracer objects. Let's add private list of game object, bullet tracer list equals new list of game object. Instead of creating a new tracer every time we shoot, we'll create multiple tracers at the start and reuse them again and again. Now let's add tracer settings variables like speed, lifetime, no of tracers. But first, let's add a header for tracer setting. First of all, we need to know how many bullet tracers we want to spawn at start. For this, let's add serialize field, private, int, no of tracers equals 300 for automatic weapons. 300 is more than enough. If your game has fewer bullets, you can reduce this value. Next, we need to know how quick the bullet tracer will travel. For this, let's add serialize field, private, float, tracer speed equals 300. This controls how fast the tracer will move from the muzzle to the hit point. A high value makes it feel like a real bullet. Next, we need to know how long a tracer can stay active before we disable it again. For this, let's add serialize field, private, float, tracer lifetime equals 2. Now let's create the initialization method that will create all tracer objects at the beginning. Let's create public void initialize tracers. Inside this method, we'll write a for loop. This loop will run according to the number of tracers we want in our pool.
Now, inside the loop, we'll instantiate the bullet tracer prefab.
Let's say game object new tracer equals Unity engine dot object dot instantiate an object. To instantiate is bullet tracer prefab. Let's spawn them in our bullet holder at start of the game. For this, let's add serialized field, private transform bullet tracer holder, and pass this bullet tracer holder as parent.
Now we'll add this tracer to our bullet tracer list. So let's say bullet tracer list. Let's add new tracer.
After that, we'll disable the new tracer. Let's say bullet tracer I.set active to false. Now our initialization method is ready. Now let's call this initialize tracer method in start a weapon controller. Open up our weapon controller script. First of all, let's add a header for bullet tracer. Let's add the bullet tracer here. For this, let's add serialized field. Private bullet tracer, bullet underscore tracer.
Now in start, let's call initialize tracer method from bullet tracer. Let's say bullet underscore tracer dot initialize tracer.
Save the script and back to Unity. First of all, let's drag the bullet tracer into project window to make it a prefab. Remove the bullet tracer from hierarchy. Now select the weapon. Scroll down till you see our bullet tracer properties in inspector.
Drag bullet holder to assign reference for bullet tracer holder, and drag bullet tracer prefab to assign its reference.
Hit play to test if we have bullet tracer spawned at the start of the game. Let's scroll down until we find our bullet tracer clones. And there they are. Now our bullet tracers are spawning at the start of the game. Let's continue the implementation of the system. Back to our bullet tracer script. Next, we'll create a method to get an available tracer from the pool. Let's add private game object get pool bullet tracers.
Inside this method, first we'll select a random index. Let's say int index equals Unity engine dot random dot range, and from 0 to bullet tracer list dot count.
Next, we'll use a for loop. This loop will run through the bullet tracer list. Inside this loop, we'll check if the tracer is inactive. Let's say if not bullet tracer list at index.active in hierarchy, then we can reuse it. Here we'll set its position first. Let's initialize the start position of tracer or pass vector3 emit pose in our method.
Now let's set tracer's position. Let's say bullet tracer list at index dot transform dot position equals emit pose, and finally return that tracer.
Now this was for inactive trace, but if our current tracer is active, then write the else block and we'll select another random index. And if all tracers are active, we'll return null. Next, we'll create the public method that will activate tracer and initialize current tracer. And we'll call this when we shoot. Let's create public void play tracer. And this method will receive a couple of vector3 for start pose and end pose. Inside this method, first we'll get a tracer from the pool. Let's say game object, current trace equals get pool bullet tracers and pass start pose. Now before activation of the tracer, let's create a new script that will move our tracer from start point to hit point.
And name this as bullet tracer movement. Now select our bullet tracer prefab and attach the bullet tracer movement script to it.
Double click to open the script and start writing the movement code. The very first variable will be target pose. Let's add private vector3 target pose. This variable stores the destination where our tracer should travel. Next, we need a movement speed for this tracer. Let's add private float move speed. Instead of hard coding the speed here, we'll receive it from our bullet tracer class so we can easily adjust it from the inspector. Next, we need lifetime for this tracer before returning to the object pool. Let's add private float lifetime. Again, we'll receive this value from the bullet tracer class. Next, we'll create a Boolean variable that will control whether the tracer is allowed to move. Let's add private bool can move. Now we need a way to tell this tracer where to go. For this, let's create public void initialized. And this method will receive three parameters: vector3, endpoint, float, speed, float, lifetime. Inside this function, let's assign the values. Let's say target pose equals endpoint, move speed equals speed, and life underscore time equals lifetime. Now we'll disable the tracer using coroutine. So let's remove our start method. And let's move the tracer in update. The first thing we check is if it cannot move, then return. This is an early return. If movement is disabled, we simply exit the update method. There is no reason to execute the remaining code every frame. Now let's move the tracer. Let's say transform dot position equals vector3 dot move towards, and it's from transform dot position to target point with move speed multiply by time dot delta time. We're using vector3 dot move towards because it's simple, reliable, and moves the object toward the target at a constant speed. The first parameter is our current position. The second parameter is the destination. It will be if our ray hits something, then it will be that point, otherwise it will be ray direction. The third parameter tells Unity how far the tracer should move every frame. Now we'll calculate the remaining distance. Let's say float distance equals vector3 dot distance transform dot position and target point. This tells us how far the tracer is from its destination. Now we'll check if the tracer gets extremely close to the target. We stop moving it. Let's say if the distance is less than 0.05. The can move equals false. Now let's create a coroutine that will disable the tracer after lifetime. Let's create I enumerator, I tracer, and pass a float, lifetime in it. Now we simply wait for the amount of time that will pass from the bullet tracer class. After waiting, we'll disable the tracer, let's say game object, dot set active to false. And finally, call this coroutine inside initialize method after setting variables and pass life underscore time in the coroutine. That's it from movement script, and back to our bullet tracer script.
First of all, let's get the bullet tracer movement script attached to our bullet tracer prefab. Let's say bullet tracer movement equals current trace get component bullet tracer movement.
Now, before using it, we'll check if it exists. Let's say if tracer movement is not null. Then we'll initialize the current tracer. Let's say tracer movement dot initialized and pass endpose, tracer speed, and tracer lifetime. So now every time we fire, the tracer is spawned from the muzzle and moves toward the hit point. Now, before getting the bullet tracer movement script, let's activate our current tracer. Let's say current tracer dot set active true. And before activating, let's detach it from the holder as well. Let's say current trace dot transform dot parent equals null. We do this because the weapon can move or rotate while the tracer is traveling. If the tracer stays parented to the weapon or holder, it may move incorrectly with the weapon. One last fix, I forget to initialize the can move bool to true. Let's do this. It's true because whenever a tracer is spawned, it should immediately start moving. Back to our weapon controller script. Inside our shooting method, we already have our raycast. If the raycast hits something, we'll call bullet tracer, .play tracer, and pass muzzle, flash, .transform. .position and endpoint will be ray hit. Point. Here I am using the muzzle flash position because that is where our bullet should start. The second parameter is the hit point. So if the bullet hits a wall, enemy, metal, or ground, the tracer will travel exactly to that point. Now, if the raycast does not hit anything, we still want to show the tracer. For this, let's add else block. If raycast does hit anything, we still need endpoint far away in the shooting direction. Let's say bullet tracer, play tracer, starting point will be the same. And endpoint will be ray.origin plus ray.direction multiplied by weapon range. So even if we shoot into empty space, the tracer will still move forward like a real bullet.
Now press play and test it. And if I start shooting, and as you can see, we have a nice bullet trail that travels in accurate direction. That's it from this video. Like the video, subscribe to the channel, and I'll see you in the next episode.